I had a question come in about Chapter 7, Tap 5. This problem gives you an algebraic expression for the demand curve and the supply curve, asks you to solve the problem both algebraically and graphically. So let's start with the algebraic solution. We've been given that demand, that's supposed to be a D, is that relationship is P equals 20 minus Q D over 10. And then our supply curve is given by the relationship P equals 2, that's supposed to be an equal sign, 2 plus QS over 20. Now, what do we do with this? Well, we remember our equilibrium condition in a free market, and that is that quantity demanded is going to be equal to quantity supplied, and that's going to let us just equate this expression to this expression, because we know in that there's going to be a single market clearing price, and these two quantities are going to be equal in equilibrium. So we can just set these two equal to each other. So algebraically, 20 minus Q, I'm just going to drop the superscript because QD and QS are the same in equilibrium. Not the same under the price ceiling that's coming, but the same in equilibrium, in the market equilibrium, competitive market equilibrium. 2 plus Q over 20. Now you've got to remember your algebraic skills to solve all this, and of course you will remember that we can add Q over 10 minus 2 to both sides of this equation. And now we have all the Q's on one side, all the numbers on the other, and we can simplify a little bit. We get 3Q over 20, because Q over 10 is 2Q over 20, and we need to do that to add it to just that single Q over 20. Anyway, 3Q over 20 is equal to 18. That's 20 minus 2. And then we can do just a teeny bit more algebra to find that Q is equal to 20 over 3 times 18. 18 divided by 3 is just 6. 20 times 6 is 120. And then we can plug that Q into either the demand or the supply curve. And if you have time to check your work, one way to make sure you're on the right track with this kind of problem is to plug the Q that you get in this algebra into both the demand curve and the supply curve. If you don't get the same price from doing either one, well, you've made an algebraic error somewhere. So you can go back and find that and fix it and get 100% on the exam. Anyway, when you do that, when you plug Q into 120, let's just plug it into the supply curve. P equals 2 plus 120 divided by 20. 120 divided by 20 is, of course, 6. 2 plus 6 is 8. P is equal to 8. And I'll leave you to plug that into the Q equals 120 into the demand curve and make sure you get the same number. Now, graphically, I haven't left myself quite enough room here, but I can still do it. Q, P. What do we have? We have a demand curve that has a y-intercept of 20, and then we know it has a slope of negative 10. That means it has an intercept of positive 200. We know that the supply, we'll label that the demand curve. We know that the supply curve has a y-intercept of 2, which is going to be way down here. And we know that that's twice as flat as the demand curve. So I'm just going to draw some fairly flat function there, call it the supply curve. And from our algebra, we know that this equilibrium occurs at a price of 8 and a quantity of 120. And for not doing that with Excel, that's scaled pretty well. So I'll start with this graph on the next panel, and let me just pause it for the moment. All right, for the next part of this problem, we've got the $6 price ceiling to deal with, and let's just graph that in, 6, and then we know that that price is a mandated price, so we know that the quantity demanded Oh, I guess I should have finished that first graph that I didn't finish. That's 120. But in this price, under this price ceiling, we know that quantity demanded is greater than quantity supplied, and the natural question here is to ask, well, how do I figure out the quantity demanded at a price of 6? And simply put, you just put you plug 6 as the price into the demand curve, and you get 6 equals 20 minus Q over 10, and that lets you figure out that Q, and of course this is the quantity demanded, is equal to 200 minus 60, so that quantity is demanded is 140, and then we have to figure out what the heck is this quantity supplied, and to get that you plug 6 into the supply curve, and you find 6 is equal to 2 plus Q over 20, and that works out to be, we can subtract 2 from both sides, and we get Q over 20 is equal to 4. We can multiply both sides by 20, and you find that Q is equal to Q quantity supplied is equal to 80. And again, scaling your graphs roughly correct can lead you to understand whether that's reasonable given your relationships in the problem or not, so you can get a visual confirmation that your algebra is correct or not. The other thing you're going to need, the only way you can analyze welfare for these for these price ceiling examples, the only way you can get a clean graphical analysis of well-being is to assume, and somewhat problematically, but we're going to just assume that these people that value the pencils highest get them. And sometimes that's true. The rich people can pay the key deposits. Rich people are more desirable as tenants than poor people because they pay the rent on time. There's a lot of reasons that rich people do get the rent-controlled items. But when to the extent that the items are just rationed out by who's willing to wait a long time in line, well, then some poor people can grab up those mechanical pencils even if they don't value them the highest. So in the real world, there's some of these low valuers down here in the demand curve can be the ones that get the pencils even under this policy. We're going to just assume that they don't, so we can get a clean graphical analysis. But that's going to mean that we got to figure out what this price here. Remember that this was the price off the demand curve, where quantity is 80. Well, that's easy enough to do, right? We can just plug 80 into our demand curve, quantity demanded equals 80, and we'll get the price that is. So demand curve is P equals 20 minus Q over QD over 10. We can just plug that in. P is equal to 20 minus 80 over 10. That is 80 over 10. That is obviously 20 minus 8, or 12. So that's where that 12 comes from. Now, it wouldn't be too hard to map the consumer and producer surplus carefully and do the algebra to find areas of triangles and such to find out numbers, but exam time is precious, and I'm okay with you just following the customary procedure of labeling the open areas and then using your welfare analysis, just referring to those areas. Sometimes in a problem set, I might ask you to actually calculate those values. But anyway, so let's go ahead and do that, and I'll keep going with blue. Well, no, I'll do black for the market and blue for the price ceiling, I'll do red or something like that for the change. Orange. All right, so let's do the market first. Oh, shoot, that was not supposed to be. I was supposed to be an arrow. Let's do the market, And we notice that at the market outcome, the area below the demand curve, above the price, consumer surplus A, B, C. So let's go ahead and tabulate that. A, B, C. And my stylus is sort of big and clumsy, and that rectangle and the table came out pretty small, but I'll do my best. Well, by the same logic, the excuse me, I still got this cough. The area below the price, above the marginal cost curve, the industry marginal cost curve is the industry supply curve for a competitive industry. That producer surplus in the market outcome is area D, E, F. I add them up. A, B, C, D, E, F. A, B, C, D, E, F. I don't know why I started with D instead of A. I think that was a slip of the stylus. There it is. A, B, C, D, E, F. Now, price ceiling example. Price ceiling case. Let's compare the welfare. All right. Well, now, under the price ceiling, some lucky consumers have gotten these cheap pencils. So and we're going to assume that at first that those lucky consumers are the ones that valued the pencils most highly. They were more motivated to elbow out the other consumers in line. I don't know. I'd put my money on the poor people in a street brawl. But anyway, even so, the rich people could hire thugs to, shove away the poor engineers in line for those mechanical pencils. Anyway, notice that some consumers got the pencils for $6, even though they would have been willing to pay much more for them. So when we tabulate up the area below the demand curve and above the price consumers paid for them across all 80 pencils that were actually sold under this price ceiling. Remember, it takes 2 to tango, so if only 80 pencils were willingly supplied, that's all there are in the market. Anyway, so consumer surplus is A, B, D. And producer surplus has fallen to F. A, B, D, F is all we get for total surplus. Let's change color here. Go to orange. Notice that consumers, the effect on consumers is somewhat ambiguous. They used to have A, B, C. Now they have A, B, D. So they've lost. Oh, I wanted my pen there. They've lost area C. Some consumers don't get to buy the pencil under the price ceiling, but the ones that do get one cheap. So consumers have gained area D. So some consumers win, the ones that get the cheap pencils, but the other ones don't get the pencils. They lose. Producers are unambiguously worse off. They sell less product at a lower price. They lose D, E. When we count up, the negative D and the positive D cancel. For deadweight loss, that's the change in well-being. We have a loss of area C, E. So the system is worse off. And for this last question, why is the deadweight loss sure to be greater? Well, it's simply because some of these low valuers could get the pencils and some of these high valuers couldn't. And in that case, the surplus, the difference between the value to the buyer and the cost to the seller is just smaller, and that would show up as a bigger deadweight loss.
Made with Doodlecast Pro.